Alright, this is going to be the tutorial for the virtual lab. This is actually my fourth time making this recording, so I'm a bit stressed out right now. I actually don't want to. Having to do this a fourth time really pisses me off. Uh, and I had to do it four times because I messed things up. But I digress. I'm gonna go through this really quickly. Alright, I'm gonna skip a lot of the BS. I'm gonna go through this really quickly. So, first thing you're gonna do. Again, this virtual lab replaces all your actual labs in class. So if you didn't do any of the actual labs in class, you can use this as a substitute, right? If you complete this virtual lab, I'll give you credit. And and if you got like a 4 or 3 out of 5 on your lab, you can do this as well, and you can try to get a high grade on your lab. Now, I can see that I can see everything that you do, right? I can see all your responses. I can see whether or not you left the question blank, right? So if you must have some sort of engagement with these labs. You cannot just answer one word to a question and expect to be done. Because if I see that, I'm just going to give you a 0. Now, I don't expect it to be perfect. I don't expect you to get every question right. I expect engagement. I expect effort. I don't care if you get it right or not. I want effort invested into this. Again, I don't care if you get it right. So you're going to go to smartsciencelab.com. And then you're going to enter your email. And so my email is going to be this. And this is your John Adams High School email. You select your class, and your password is going to be science. Now, my password is not science, so don't even try. But your password that you're going to use is going to be science. Right? So you're going to log in, and you're going to see a few labs. You're going to see horizontal projectile motion, pendulums, energy, spring, energy conservation, and Ohm's law. You're not going to see vertical projectile motion because I removed that. So horizontal projectile motion is going to make up for lab 7. Pendulums and energy is lab 8. Springs and energy conservation is lab 9. And Ohm's law is going to be an extra credit lab. So you can do it if you want to. You don't have to if you don't want to. Okay, so again, this is all just to make up your labs. So let's go for the first lab. All right, let's start this lesson. Sure, let's reduce the size. So you're gonna watch this video right on the bottom right here. It's a 35-second long video. You're gonna watch it, and after you finish watching the video, let's just say that I already finished watching it. You're gonna answer these questions on the right-hand side. Now again, I want you to answer it diligently. I don't care if you get it right or wrong. I want you to answer it with effort. Now you're gonna click submit. They're gonna tell you what questions you got wrong and what are the correct answers. And you click close and you skip and then you move on to the next part. And the next part requires you to choose a hypothesis. And the problem question is, how does a horizontal velocity change over its trajectory? And so you're going to choose a hypothesis, choose one of these things. So let's just choose the first one. It doesn't matter if your hypothesis is correct, right? It doesn't matter. It's a hypothesis. But I still want you to choose it correctly. I want you to read through it all. And then you're going to see this video, right? And so this is the data taking part. And this is the explore portion. So you're going to click brass and maybe just choose an angle of 60 degrees. And you're going to press the play button and it shows it being launched at 60 degrees. You're going to wait for this to be over. And now what's going to happen is that there's going to be a mini video on the screen. Don't click anywhere else because this mini video tells you how to do the lab. It tells you how to take data. Right? So basically I'll explain right now. So it says here on the bottom left, click on the center of the projectile. So I'm going to click on the center of the projectile, and there's the X right there. And then we'll click X next. Right, so click that. And you can actually press enter to keep going as well. So you don't have to keep clicking next. So enter, click the middle again. You don't have to be precise. Just get as close as possible to the center of this projectile. It does not have to be precise, and so. All right, cool. Now we're finished that, and you see on the graph on the right-hand side, we just plotted a graph. And this, again, this is a DT graph. This is a position time graph. This is a distance time graph. So guess what? Guess what the guess what the slope means, right? So the slope of a position time graph is your velocity. It is your velocity. So the velocity, the horizontal velocity is more or less constant, right? Because it's a straight line, because that's your velocity. So let's actually do this right here. So 45 degrees, brass. So again, so we're gonna do the same exact thing. X, 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 enter, 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 sure. And perfect. And so now you have two graphs, and you're going to do the same thing for all the other degrees, but because for the sake of this tutorial, I'm just going to leave it at 2 angles, right? But you want to do it for both aluminum and brass, and if I look at your data, I expect all data to be taken. Let's just take a look at these two graphs, okay? So you have these two graphs combined, so this is brass 60, and this is brass 45, and you'll see that in all graphs that your slope is constant. And if your slope is constant, that must mean your velocity is going to be constant as well. So based on your data, again, if you move on to the next part, evaluate, right? You can move on to evaluate now after you finish all the graphs, you'll see that the graph picture is constant, okay? So now you realize, oh, it doesn't matter how does horizontal velocity change over its trajectory. Your horizontal velocity does not change because your slope is constant. And now we're going to want to answer these questions on the side, right? What is the dependent variable? The dependent variable is usually the y-axis. Dependent variable is usually the y-axis. The definition of the dependent variable is a variable that changes based on another variable. So as time changes, your horizontal distance changes as well. And so your dependent variable is your y-axis. It usually is. So it's distance. Which bound best describes the horizontal speed of a projectile over time? We just talked about it. Your slope is constant. That must mean your horizontal distance is constant as well. Number 4, you're using the formula. You're using the formula V is equal to d over t for number 4. Which angle in the lab produced the highest horizontal speed? Well, the greater your slope, the greater your speed, right? The greater your slope, the greater your speed. So the higher, huh? Well, that's inaccurate. That's inaccurate. So I would just do V is equal to d over t. See which gives you the greater speed, right? See which gives you the greater horizontal speed. All right, based on the angle. See which one gives you greater speed. If you grab speed, everything else I would just answer. So it doesn't matter. I don't care if you get it correct or not. So let's look at this. Sure, sure. Explain. All right, those are your angles. And then this is where you explain. I expect something typed into this. I don't expect dribble. I don't expect BS. I expect something to be typed into this, into these boxes. Okay, so that's very much the tutorial. If I went too fast, I apologize. It's my 4th time going through this, and I just want to get this over with. All right, good luck.